Hi folks. A friend of mine came by and brought me a Marantz 1070 he says is not coming out of protection. So we're going to pop the cover off and give it a quick visual exam before we power it up and observe any symptoms we have. But before we do, I want to talk briefly about protect circuits, how they work, what they do, and why sometimes they won't close a relay. Basically, your protect circuits are there to protect your speakers, not the amplifier. It's a relay that opens up and removes the output of the amplifier or the amplifier modules from the speakers. And that's its sole purpose. And what it does is it detects excessive DC, the kind you would get from a shorted output or something malfunctioning in one of the amplifier channels. And there are only really two scenarios where that relay won't close. The first one being a problem with the amplifier itself, or the other scenario being a problem with the protect circuit itself. So my usual MO when I have a problem like this is I just probe the output of each channel, usually at one of the emitter resistors, to see if there's excessive DC. And if I don't see that on either channel, I will focus my efforts on the protection circuit itself to see why it's not pulling the relay in. Most commonly it's in the amplifier, but we have seen on my channel at least one. I remember the Carver M500T had a problem in the protect circuit. There was nothing wrong with the amplifier itself. So anyhow, let's pop the cover off and see what we got. Okay, so after getting the covers off of this and giving it an examination, I determined that it's really hard to get to the emitter resistors on this. They're usually one of the easiest points to get to. But of course, this amp has to be just a little different. So what we're going to do is we're going to tap one of these binding posts that go to the output transistors. And we only need to look at one emitter on each channel just to see if we have any offset. So I'm going to take a look at J716 on this transistor, and on this channel we'll take a look at pick a number here, J717. So we'll just take a look at those and see what we have for offset. And if we don't have any, we're going to start to focus here on the protect circuit. Okay, so I have my meter grounded to the chassis here with a clip lead going to the common terminal on my meter, and I'm going to turn the amplifier on. And we're going to see if we have any kind of DC at J716 and 717. And that is going to be this wire here and this wire here. So 716, we have no DC output. 717, we have negligible. That is about 30 millivolts. Yeah, that's not enough to put this into protection. Usually it takes a volt or two. We'll adjust the offset after we find the problem, but first, let's find the problem. All right, in order to get a better understanding of what we're looking at here, I printed out a section of the schematic that deals with nothing but the protection. Now, here's our relay. Here's our relay coil that we have to energize. When we energize it, you'll see that, by the way, it is shown in the energized position here, that we will have continuity from our output Zobel networks. These are coming from the output stages and going through the relay contacts out to the speaker. And it shows that on both channels. And therefore, the voltages that are notated on the schematic should be the voltages that we get with the relay energized. If we look here at J709, this is where the DC, the power, the whole thing comes in, goes through our 772 and goes to the circuitry for the relay drive, and it goes to the relay itself through here. We also monitor for excessive DC through these two 5.6 k ohm resistors here and here. They tie in and go to the base of H726, and then we go to H727 and 728, which will actually energize the relay. And what will happen is, in order for this to be energized, we will get 0.7 volts here giving us 1.3 volts at the collector. That we'll see at the base of this transistor. We'll drop 0.6 through the base emitter junction, and that'll go to feed the base of H728 and drop 0.6, leaving us at 0.7 volts here. This is known as a Darlington pair or Darlington transistor. Basically, the emitter feeds directly into the base of this. They have tremendous current gain, so we need current to pull the relay in. So we need to see what our voltages are at 726, 727, and 728. So let me get this out of the way. We'll take a look at those. Everything is on the output board. It's a little hard to get to, so I'm not sure how well you'll be able to see, but we'll try to get the camera position so we can both see what we're doing here. All right, the transistors I need to probe are buried under here. I believe 2 of them are here and another one is up under this big filter cap. So I'm going to have to move the amplifier. You're probably not going to be able to see me probe the transistors, but we're both going to watch the meter because that's where the action is, and I'll give you a running commentary and tell you what we're seeing and what we're supposed to see. Okay, I'm going to start by probing H726, the first of the 3 transistors. We're supposed to have 0.7 at the base, 0 at the emitter, and 1.3 at the collector. So let me see what we get. So the base is giving us 0.04. That's a little low. The collector is giving us 1.28, so that looks good. And I'm not going to bother with the emitter because that goes right to ground, but the collector looks good. That's where the rubber meets the road on this particular circuit. So now we want to look at H727. That's supposed to have 1.3 volts at the base, and it should be 1.28 because it's the same thing that we saw at the emitter of the previous transistor. And we get 1.28, 1.29. That's very good. The emitter should give us about 0.6, 0.7, very good. And the collector is also supposed to be 0.7, and that is. So that looks good. And we have finally at H728's base, we should have 0.7. We do. Our emitter is also, our emitter says 0.7, but we clearly see that's a mistake on the schematic. And I'll show you why that is. And the collector is 0.7. I believe we have a bad relay. Okay. Now let's see if we look at the diode H729, which goes right across the coil. We should have 0.7 on one side and whatever the supply is on the other. All right, so we have our 0.7, and the other side of that gives us 24 volts, and it's a 24 volt relay. So I think we have a bad relay. So it's going to take a little bit of disassembly, so let's shut the camera down, take this thing apart, and see what we get. All right, I'm just going to show you the disassembly of this real quick. By the way, I'm really lax about mentioning this, but if anybody's trying this at home, remember, you're sticking your hands in here at your own risk. I'm just showing you how I do this. Should you attempt to do this yourself, I'm not responsible for any mistakes you make, okay? In our society, I just feel like I need to say that. Anyway, there are 4 screws that hold down the heatsink assembly that the output board is mounted on. They have to come out, and then the board itself comes loose. And then we're going to have to take the board off the standoffs here. Should be 4 screws on that. But most important, and this is why I wanted to turn the camera back on to show you, you have these bias diodes here and here that need to be detached from the heatsink assembly before you lift this board up. The leads tend to be very delicate. These are extremely hard to find, and should one of them break off, you're going to be in a bit of a pickle because finding them, as I said, is quite difficult. So I wanted to point that out before I did any disassembly on this. So we've removed it, so the heatsink assembly is free. We will loosen the screws and nuts so we can take the bias diodes free, and then we should be able to tilt the board up And I want to take a look at that relay because I believe the relay itself is where our problem lies. Okay, so I've got the board loose. You can see these bias diodes. I don't know if this camera's focused on these, but they are kind of horseshoe shaped and they go up under these screws. So all you have to do is loosen them. You don't have to take them out. Just loosen these so you can get these off. And when you put them back in, you can always dab a little bit of heat sink compound on here. It'll help facilitate the heat transfer and make sure that the output stage bias tracks temperature changes. So I got the board lifted off of here and I unsoldered our protection relay because we're going to take a look at this. I believe the relay itself may be the problem. Okay, this is our protection relay. Now, a relay is nothing more than a coil that pulls in a set of contacts, and the coil is always the two wires, two contacts that are separated at one end. They're easy to find. These are the contacts for the speakers that go between the speakers and the amplifiers. These two at the bottom are the ones that we're going to want to take a look at. By the way, I don't know if you can hear the noise, but my air conditioning system died here and I had to have the air handler, I asked to have the air handler moved out of the attic and over to here. So next to my bench now, we have this noisy rig. But it sure makes it a lot more comfortable in the house. So basically, the easiest way to check your protection relay is either put 24 volts into it and see if you hear it actuate, or you can just check it with an ohm meter. So if we just check the contacts, if we check the coil with our ohm meter, we should see continuity. And we don't. This relay is bad. That is probably the whole problem. I don't know if I have anything I can put in there, so let me take a look and see what I may or may not have. Okay, so it turns out that these are very difficult, if not impossible, to find relays. I haven't found anything that looks like it's going to be a modern replacement. So we are going to kludge a relay in. This is an Omron LY24. This is an LC24. They have physical differences and the pins are not laid out in the same manner. So what I plan to do, since we have the room to do this, is in the interest of getting this working again, I am simply going to hot glue a relay, this relay right here, and we'll run some flying leads to the circuit board. And that'll work fine. I would be hesitant to do this if it was something I was going to be shipping across the country, but my friend has a engine rebuild shop, and this is going to go from here to his truck to his shop where he'll sit on the shelf for the next 10 years or so. So it's not going to be moved around, it's not going to be shipped. And my only concern would be the relay would detach. I'm just going to hot glue it in there. This will be completely reversible. I don't like to do mods, but sometimes we just have to come up with ways of making things work, and this is one of those cases. So I'm going to solder some leads to this. We'll solder it to the board, put it back together, and see what we get. All right, so I have leads soldered onto this. We'll cut them into shape once we get this closer where it is, where it's going to live. And what I'm probably going to wind up doing is just soldering it right to here. There's plenty of clearance between the cover and this, and we'll cut the leads so there aren't so many and try to make this as clean an installation as possible. I have the hot glue gun heating up here, so we will glue that right to this, and then we will see how long these leads have to be. And point at that. Here you go. We'll see how long these leads have to be. You will glue it right about to here. I like hot glue. It usually holds pretty well, but you can get it off when and if you want to. So we'll do that, cut them, solder them in, maybe tie wrap, kind of clean it up as much as possible, and then put this all back together and see what we get. By the way, before I put this in, I just want you to see what a good relay looks like. They're usually around 600 ohms across the coil. And if we just go across the coil on this one, we get 631 ohms. That's what a good coil should look like. When you have an open, it's just never going to work. These are DC relays. You can also test them with a power supply, but the meter tells you all you really need to know. Okay, so we got this relay in. I hadn't dressed up any of the wires there because I just want to test it, make sure everything works before I put everything back together. I put a few screws in the circuit board to secure it, put the bias diodes back on here, and just want to see if it's going to work before I put everything back together and clean up some of the wiring. So let's turn it on. I heard the relay click, and if we look at our scope and distortion analyzer, we have output. So it's working now, but I need to tell you about an error I made when I was testing this relay. And I'll get okay, and there's about max, about 30 watts. I'm not sure what these are, but I suspect that's good. So we'll clean this back up, clean up all this wiring, put all the screws back in, but I need to talk to you about this relay. So let me get set up and I'll show you the mistake I made and why I made it. Okay, so here's a relay I took out of a different Marantz. I think it was the 2325. And if we go across the coil here, they're usually around 600 and some ohms. And this one is no different, 674 ohms. Now, the way these are set up, you have a common set of contacts, then you have normally closed, normally open. So I'm going to put this in diode test mode or continuity so we can hear it. Okay, and that is our common contact, normally closed. This is normally open. When the relay is energized, it'll close, but not until then. So I have a power supply set up that's putting out about 24 volts, and when I do pull this in, you'll hear it click. And we no longer have our this is our common. It's a lot easier when the pins haven't been cut off. But the mistake I made was almost all relays have the coil set up like this. This one does not. This one has the coil set up here. And our commons are what I thought were the coils. Now, this tests good. Okay, if we go across our coil, we get 665 ohms, which should be good. However, if we go from our common and pull the coil in, oh my God. I gotta stop buying these cheap spring mini grabbers. Ever having to bend these back into shape to use them. The Pomonas are a little more expensive, but you know, they're worth it. Especially when they break off like this one just did. That's the valves. Okay, and I pull the relay in. These are so bad, it's really hard to get a, let's try these. Yeah, the relay, the coil's not bad, but the relay still isn't working, and it's not making that distinctive click that they're supposed to make when they are working. So there's definitely a problem with it, but my mistake is I assumed, and it bit me, almost bit me, that these were the coil, because almost all these relays are set up like that. This one doesn't. Unfortunately, they have a little graphic on here, and you have to get it in the light in order to be able to see it, but it clearly shows the coil is actually between these pins. All right, so I wanted to point that out. Fortunately, I checked it before I wired all this in, and I made no errors, but I did make an error earlier when I told you how to test this particular relay. Most every relay is going to test from these pins. Okay, so we got a successful repair. It's not the most beautiful thing I've ever seen, but I'm going to clean this up and we'll take one final shot and look at it, and then we're going to end this video. Okay, so I got everything put back together, got all the screws back in. I put a couple of tie wraps on here. You're basically putting lipstick on a pig, but it's a better looking pig now, you must admit. Anyway, let's crank a little music through here.
I wake up, I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden, I don't look at anything the same way. Gotta build up.
Okay, everything's working. I don't like doing repairs like this. I don't like having to kludge things in, but sometimes we have no choice in the matter. When parts are no longer available, we have to make do with parts that are available. So anyhow, this was a successful repair. I'm going to put the covers back on, but I think we're going to call this video a wrap. And as always, I hope you enjoyed it. Hope you learned something. And as always, I like giving back to the community that has given me so much. Thanks a lot, folks.